So this lecture is on biomechanics in the NUCA world, the four basic types, the variations, and generally considerations. So the basic types, NUCA and NUCRA or UCRF, have found that X-ray findings are grouped into four general categories. These are distinguished by head tilt in the frontal plane, C1 plane line, whether it's high or low, and lower angle side, whether it's ipsilateral or contralateral in relation to the laterality. Each type represents unique challenges to overcome for the optimal outcome, and some cases fall between the distinct groupings, requiring innovative approaches. So even though we have the four basic types, not all cases fall within those distinct borders. So when we did a statistical analysis on what sort of misalignments, prevalence or occurrence we have, this is the way that it broke down. Basic type 1, represented by the light blue line, represents over half the cases that we see, so about 52%. And so what does that mean? Well, maybe that in the event of a misalignment occurring, the chances are that it'll fall into a basic type 1 pattern are roughly 50%. So we can think of it as maybe the most stable form of misalignment. Then we look at basic type 2, represented here by, what color would that be? Well, let's say light brown. And those represent, considering there's four basic types, pretty close to a true quarter, so in 23%. And that's characterized, well, we'll go through that in a minute. So basic type 3, here the chiffon, would that be? All right. Color represents a small percentage, just 7% of all cases. And it's, it's a smaller version in terms of not having a cervical line measurement. So the cervical line is perpendicular. And then we have basic type 4s, which represent the remainder, or 18% of all the cases. And that would be some sort of a muddy yellow. So when we look at the basic types, we have film analysis of the nasium that yields the basic type of the case. Each basic type has attendant support requirements relative to the center of gravity of the skull, and we talked about the center of gravity in an earlier broadcast. Additionally, the type of support and where in the support the center of gravity is placed is dependent on the type found. Finally, the line of drive, or the calculated vector, the reduction pathway, is specific to each of the cases. So here's a stick figure representing a basic type 1. So let's orient ourselves. So prior, when we looked at it, we had a red line for the central skull line, but this is represented here by the black line. The cervical line here is also a black line, is below the atlas plane line. The inclined line is the APL, or atlas plane line. And then so we have our reference horizontal line here, and this red line represents the vertical axis line. So when we look at a basic type 1, the CSL, or the line through the cranium, is either vertical or tipped away from the site of laterality, reducing the acuteness of the upper angle. So, for example, in this case, let's say that we had, if we were to measure the angle of that atlas, let's say it was at 10 degrees, which of course would be a huge listing. But so if the central skull line were vertical, then each of the 10 degrees of the elevated plane line would also equal a degree of laterality. So in that case, we would have 10 degrees of laterality. But the central skull line can also tip away from the hide side, and it can tip as much to still maintain an acute angle on that right upper quadrant. The acute lower angle is on the side opposite laterality, so we have a right upper laterality here, and we have a left lower angle here. So that makes for an acute angle on the left side. And the final characteristic for a basic type 1 is that the atlas plane line is always high on the side of laterality, which when we did the factors for it, recognizing that would give it a positive value in the calculations. So in a basic type 2, we have a central skull line, or CSL, that is tipped into the side of laterality, increasing the acuteness of the upper angle. So in this case, once again, this is the black line here. It's actually tipped into the side of laterality. We have a right acute angle and right head tilt. The example that we did earlier actually demonstrated that, although there the plane line was slightly higher. The lower angle acuteness is on the same side, so we have a right lower angle for the cervical line, and we have a right laterality. So these would be an ipsilateral. And the APL in these is typically on or near horizontal, so not a huge deviation of the APL in the frontal plane in a basic type 2 listing. And these, like I said, are about 23% of the cases. So a basic type 3 is distinguished by the fact that the cervical line is perpendicular to the APL. So that means that there's no lower angle, as denoted here by zeros on either side. And the plane line, well, all right, so let's start then with the CSL. The CSL is forming the majority of the laterality by tipping, as in a type 2. The plane line, in these cases, in a typical type 3, is on or near horizontal. So it's basically just the head that has turned in the frontal plane down and causing laterality to form. And these represent 7% of the cases we see. So in a basic type 4, this is kind of a combo misalignment. So the central skull line is tipped into the side of laterality, which is the same as what a type 2 represents. The lower angle is acute on the opposite side of laterality. So if we have a right upper angle, we have a lower angle that's on the left side, so it's contralateral acute angles, and that would be like a type 1. And the APL is generally high on the side of laterality. Once again, this would be a typical case. And so in a type 4 then, you can see that the potential for laterality being a higher level of acuteness is there because in this case you have a plane line that is elevated on the right side, and you have compounding that a central skull line which is tipping into the right frontal plane. So this acute angle has two components to it. One is the head tilt, the other is the fact that the plane line is elevated. So let's look at the headpiece. So originally the headpiece only had this square component, and then roughly in the I would say late 80s, early 90s, a rounded section was added. And so then for clarity in teaching, what we did was we split the square headpiece into thirds, labeling from its caudal end A, B in the middle, C is on the cephalad end, and then the headpiece can be rotated and the D support can be used. And the D only has one support on it because being a rounded support, any point that is the highest point is the pivot point. There's also a multi-support headpiece, which I don't have a slide on, but it has a triangular plate for supporting, that's movable, for supporting the whichever portion of the skull the doctor chooses to support, and then it has side plates that can elevate to cradle the rest of the cranium, and it was developed to aid in reducing large transverse plane misalignment factors. Excuse me. So the headpiece, the square portion of it is the A, B, and C is used for types 1 and 4 typically. The D section is used for types 2s and 3s, but these are just guidelines, they're not rules. Ultimately, the doctor must decide what the biomechanics demand for a given case. So the factors that we have available to play with in terms of the optimal reduction is where to place the head, which support to use, and making any additions or subtractions with the height vector. So now for headpiece position, for basic type 1, the headpiece is always set so that it is horizontal. The center of gravity of the skull will assist in the reduction based on the support point. So here you can see that this is the square support. So this would be A, B, and C here. But in a type 1, this is level. For types 2 and 3, using the D support, so here the square headpiece has been rotated to present the rounded headpiece here, so this is the D support. Or for type 4, which you would use the support at C, and of course this would be on that end, the parietal end of the headpiece is tilted down. In other words, this portion is moved down to allow the center of gravity of the skull to roll towards horizontal. In other words, in a case like this, let's say the head tilt would be, so if the patient were lying facing us, it would be a left listing. Patient would be laying on his or her left side. I'm sorry, right side, left side up, left listing, and with left head tilt, this would allow the head to kind of fall away from the subluxation. So we also have different skull positions. The range of difference of support for the basic types is confined to an area from the tip of the mastoid here outlined to a point that is horizontally aligned to the lateral canthus of the eye. This area is only about, inch or so, maybe inch and a half. I think I have it measured here. So not a huge amount of skull available for delivering, or patient placement for delivering the adjustment.